Hey class, how are you doing? This is the instructional video for lab number 5, which is our VO2 max lab. So this is a super important thing in regard to the totality of exercise physiology. So important, in fact, that this lab is going to take 2 weeks for us to do, and that's because we have 5 different protocols and 5 different protocols with 6 different tests. So that means that one person will be doing each protocol, and then there is one protocol that is actually going to be done twice, which is the Bruce protocol, probably the most famous protocol in the totality of like stress tests and maximal graded exercise tests. So a couple of things to start talking about. Um, is what even is VO2 max? So if you read right here, maximal oxygen consumption, or VO2 max, is the measured of the highest rate that oxygen can be taken up into the blood, transported to the tissues, and utilized by the mitochondria in order to make ATP, specifically within the skeletal muscle. Now, a big thing I want you to know is I always hate it whenever it does that passive voice stuff. What VO2 max is. Max. What VO2 max is equal to Q multiplied by, well, here, let's just do an X. A V O 2 difference. So what this means is that VO2 max is the maximum amount of cardiac output multiplied by the difference in arterial oxygen minus venous oxygen. So hopefully everyone knows that Q is equal to um, uh, CO, which stands for cardiac output, which that's just equal to our heart rate multiplied by our stroke volume. SV, I'm sorry, not an L, stroke volume. So effectively, this part of the equation is called the transport side of the equation. So your heart has a maximum heart rate, and the left ventricle has a maximum amount of fluid that it can pump per each heartbeat. So the max there is effectively cardiac output, the maximal cardiac output. Now this other side of the equation, AVO2 difference, that is effectively the utilization aspect of the equation. So how much oxygen is in your arterial blood minus how much oxygen is in your venous blood, that makes it to where we have an assumption that all of that oxygen went into whatever tissue that it's going over, being transmitted through the capillaries, myoglobin, so on and so forth, and hopefully used in the mitochondria. So right there, I would know that. That's going to be really big, important stuff for this class. So I'm sure I'll talk about it more prior to beginning lab. So 2 big aspects to know: absolute VO2 and relative VO2. I would know the difference between these. And the biggest things to understand here is that liters, so this is going to be a smaller number. Milliliters, this is going to be a bigger number. And also, absolute VO2, this has nothing to do with how much an individual weighs. And relative VO2, this has everything to do with how much an individual weighs. So here, let's break these down just a little bit. Absolute VO2, this is the liters of oxygen taken up per minute, whereas relative VO2 is the milliliters of oxygen taken up per kilogram of body weight per minute. Now, with both of these, there's different predictive capabilities of them. So absolute VO2 is a little bit better at predicting aerobic performance in exercise that isn't so much weight bearing. So things like cycling or rowing, where really it's the gears or whatever you're pulling against that you're actually moving, not necessarily moving yourself through space and time. Now, relative VO2 is a little bit more predictive of aerobic performance in uh, types of sports where you're actually moving yourself. So running is probably the biggest one that all of us think of. So next thing here, there's a wide variety of maximum like oxygen or VO2 max tests. So in general, here are a couple aspects of them. So they should always involve large muscle groups because whenever we're testing these, we're really testing the oxygen capacity of whatever the primary muscles utilized. So if we're running, it's mostly glutes, hamstrings, a little bit of quad, some calf or gastrocnemius. Whenever we're cycling, if somebody is somewhat unskilled in cycling, it's mostly quadricep that we're testing. So it's important for us to use large muscle groups, but keep in mind that the test, there's not one good VO2 max test that actually tests every single muscle in the body, and we're kind of limited by which test that we're actually doing. So, like cycling, a little bit more quad aerobic capacity, running a little bit more hamstring, glute, everything else. So that's kind of an important thing to understand in interpretation of these results. So the task should involve large muscles. The workloads should be measured and reproducible. The duration of work should be at least 2 to 3 minutes. So we need to get to an aerobic steady state before we can even uh, uh, assume anything about oxygen consumption. Because if we just had a 30-second stage, then it's likely all anaerobic, and we're not even testing our oxygen capacity. Um, Next thing, mechanical efficiency and work should be similar among uh, different individuals within a population. And really, that has to do with an individual's experience with cycling or running or arm cycling. Individuals who are less experienced with running are typically less mechanically efficient at it. So then the VO2 max prediction isn't going to be as great. Next thing, the test should be appropriate for the population tested. So if we have like some Tour de France cyclists testing their VO2 max on an arm cycle ergometer or on a like Bruce protocol running on a treadmill, that's not really what we want to do for them. So uh, there's an important thing for us to know there. One variable that we likely haven't talked about in class yet is SpO2, which this just stands for peripheral capillary oxygen saturation. So normally it's somewhere around 95, 96, 97, 98, 99, or 100%. And at the tail end of an exercise test, our hemoglobin actually gets a little unsaturated because, well, our muscles are essentially taking up so much oxygen. And we actually have pulse oximeters that measure this. So I just put a couple of things in here that I thought was kind of cool about it. One thing with hemoglobin, that's the American way of spelling it. With that weird A in there, that's the British way of spelling it. So if you ever see it either way, both are correct. Just one is a little bit more accepted in different countries. Next thing. Uh, to memorize and to really know, there are 4 criteria for understanding if we actually got to a maximal aerobic test. So the first one is that blood lactate level is at or above 8 millimoles per liter. So in lab, we can actually measure this. Now, I'm not going to force anyone to measure this for this 2-week lab, but I think it would be good if you did. Um, but I only have so many lactate strips, so bear that in mind. Another thing is heart rate needs to be within 10 beats of age predicted heart rate max, which if you don't know, this is 220 minus your age. So if you're 20 years old, that means that your age predicted heart rate max is 200 beats per minute. So if we're not within 10 beats of that, meaning if we don't get your heart rate up to 190, that this is likely not a maximal test. So there are some differences in individuals. Like whenever I was all of your age, my max heart rate was actually a little bit below what was predicted from my age, from 220 minus my age. But we knew that because I tested it numerous times. But if you don't know what your actual max heart rate is, this 220 minus your age will at least get you in the ballpark. Another thing from the previous week's lab, ventilatory threshold, the R or RER value needs to be above 1.1. If we don't get to there, then it's likely not a true max test. And lastly, RPE. This stands for rate of perceived exertion. So this is essentially a subjective, where you ask a person how they're feeling on a scale of 6 to 20. And here I'm going to show you this right here, 6 to 20. So 6, no exertion at all, 20, maximal exertion. So you ask them where they're at on that, and they say something like 11, 12, 15, 17. If they don't say at least 17 on the final stage, that means that, well, this likely isn't a maximal test. Now, something peculiar to know. Why is it 6 to 20? Why do you think? Now, what if we added a 0 to all of these numbers? Does that look like any potential variable that we could get during an exercise test? 60? Maybe that's a resting heart rate. 200, 220 minus your age, 200. That sounds like a max heart rate, right? Isn't that kind of strange? So that's actually how this was derived. It's from a guy named Borg. So it's the Borg rating of perceived exertion scale. That's essentially what that is. For this lab, you're going to have to put people into normative categories. So this is normative categories based upon their relative VO2 max. You can see that ml per kg per minute. So here's ages, and also here's excellent, good, above average, and all sorts of things like that. So bear that in mind whenever we're going through this. So our very first test, this is the treadmill test, and luckily for all of you, I gave you an Excel document, and I'm going to talk about that here in a little bit. Now, this treadmill test, you're going to have to consult with the one person in particular who is doing this, because we have to have a self-selected pace. So what I mean by this, let's go on over here. So treadmill VO2 max. We need to warm up for 3 minutes, so 0 to 3 minutes, 3 miles per hour, 2% grade incline. So we might actually be measuring their actual oxygen consumption. We could get a predicted VO2 from everything down here. I'll talk about that momentarily. We need to measure their heart rate. We have numerous heart rate monitors. RPE, asking them at each level. SpO2, I'll show you how to use a pulse oximeter. RER and lactate if we're actually measuring it. If you're not, it's okay to not have those. So here, let's look at this. Self-selected pace. So what this means is we need to pick one pace that they're going to be at for the entirety of the test. So if they choose to run at 6 miles per hour, that means they're always at 6 miles per hour. Does that make sense? Hopefully that does. Well, here, I'm going to move that back to right there. So it's really whatever pace they want to run at. Myself, I've got short little legs, so whenever I do this, I normally do 5 miles per hour, because once you start getting up into those higher inclines, going faster is a little bit more difficult. But if you're a relatively skilled runner, 6, 7, 8 miles per hour is perfectly fine. Now, something that I already have programmed in here for you, whenever they're at their very end of the test, we can actually get their VO2 max right here. So let's say that they weigh 170 pounds, give or take. Converts that to body mass, kilograms. Let's say they're going at 5.2 miles per hour for whatever reason. That's, well, that's meters per minute right there. And then here, percent grade, let's say for their final like 3 minutes that they were able to maintain, they were at a 14% grade, super high, right? So what this is, this number right here, that is our relative VO2 max. So if someone was able to get to this stage and complete it, that means that they are at a 48.9 relative VO2 max. Their absolute VO2 max is 3.77 liters per minute. So that's how that works. Now, I highlighted these spots. Don't write anything in any of these other areas because there's already equations written in there. So, yeah, be cool to me on that because I don't want to have to go in there and write the equations again. Next thing, insert a scatter plot, primary and secondary y-axis, predicted VO2, and heart rate. So on one y-axis, VO2, on the other one, heart rate, and stage on the x-axis. We've done quite a bit of making graphs, so you should be able to do this by now. Normative category and what their VO2 max is. So here I mean relative VO2 max. So tell me their normative category. What I had before, let's say it was a female who was at the 48 or so, and they were within the 18-25 age range, they would be in the good normative category. So hopefully that makes sense. Next thing, cycle ergometer. This one you're going to have to be cycling like on a metronome, so 50 revolutions per minute. And if you have difficulty with that, I will help you do that. Effectively, here is the stages for it. So 1 kilogram, 50 watts, 2, so on and so forth. Remember, the trays already weigh 1 kilogram, so you'll just be getting their heart rate, rate of perceived exertion, and that'll essentially be everything that you're doing. We might be getting the actual VO2 max by hooking someone up to the metabolic cart. However, the predictive VO2, you would get that from this right here. So body weight, let's say they weigh 200 pounds and they have 6 kilograms on the bike. Now that's 6 kilograms including the tray. So the tray plus 5 kgs on there. There's their relative VO2, there's their absolute VO2. So you'll have to fill that out for every single one of these categories. Hopefully this makes sense how this is going. 0 to 3 minutes, 3 to 6, so on and so forth. One thing to know, I expect nobody to get to a full 30 minutes. So people typically stop somewhere within this region. All right. Next thing, so only one person is going to be doing the cycle ergometer. Now the arm ergometer, pretty intense test right here. Notice that the stages every 3 minutes are only going up by half a kilogram. That's pretty common for like arm ergometers going up by a smaller rate than the leg ergometers. So how that works, arm ergometer, placed it at the very end over here. Essentially the same thing, put someone's body weight in. Let's say that they're 115 pounds, weight on the bike. I don't know, let's say they got up to 4, and then revolutions per minute, it's always going to be 50. So that would be a super high VO2 max. I doubt that we would ever see that. It could happen though, I guess. All right. Next thing. So only one person doing the arm ergometer. Then answering a couple of questions about it. Here, the bulky protocol. This is a well-known walking protocol. So there's actually a different protocol for males and females. So if we look over here, bulky, I actually have it here for you. So stage, time, gradient, speed. So males stay at 3.3 miles per hour the whole time, and females stay at 3 miles per hour the whole time. Now, interestingly, males actually go up every minute in their incline, whereas females go up every 3 minutes in their incline. So just keep that in mind. Down here, how we actually calculate the VO2 max. I want you to read this and see how it's done, but I have it in here for you. So you have to really keep in mind exactly how many minutes and seconds the person is moving. So let's say an individual is like a male is going 13 minutes and 27 seconds, say. That would mean that their VO2 max is 34. Now, let's say a female is going, I don't know, let's see, 16 minutes and 2 seconds. That would mean that their VO2 max is 27. So uh, that's essentially how that is calculated. Mess around with the Excel document, make sure that you understand it. Next thing, Bruce protocol. This is the one, super famous protocol. It's probably the most used. If you've ever seen a stress test, it's almost always a Bruce protocol or a modified Bruce protocol. So something like this. Two individuals are going to be doing this. So heart rate RPE, two different people, and we're going to be comparing them. Here's how you actually calculate the VO2 max. Quite a bit to do with this one. But go on to here, Bruce protocol, how this works. Fill out everything going on. And here, let's see. Let's say they make it to 12 minutes and 2 seconds. That would mean VO2 max is right there. Now, interesting thing that I kind of did for you, if you've made it through this video, so far 20 minutes, sorry. If their heart rate is 90, RP is 7, 100, 115, 125, 135, 145, whatever, 8, 9, 10, 12, 15, something like that. I already have that programmed in for you, so there you go. Now only have it programmed in once, so make sure that you knock that out and do the second one. Then last couple of things, there's a couple of overall questions. Answer the VO2 max equation, the equation I talked about at the beginning of this video. Criteria for determining the VO2 max, talked about that. And tell me the criteria that you actually measured in class. That might be different for a couple of ones of us. Hopefully this makes sense. This lab is going to take 2 different times. So my idea is that you run 3 tests in week 1, 3 tests in week 2. Now granted, you can do it however you want. 2 tests one week, 4 tests the next week. Just we're going to have to be sharing a lot of different things. And I'll be helping you with all the different protocols as we go along. All right, see you in class.